Hello and welcome to Tips and Techniques for Troubleshooting Performance Issues in the Cloud. My name is Steve. I'll be your moderator today. Thanks for joining us. We certainly have a lot for you to take away, some good tips and techniques from today's workshop. Whether you're planning to migrate to a public cloud or in the process of doing that, or maybe you've already done it, you'll find this workshop very informative and helpful. So let's get started. Today, we're going to be, anyway, thanks for joining us. We're going to, in today's workshop, we're going to learn about some instruments, tools, and tips and techniques for troubleshooting and aiding security in the cloud. These interrelated topics will be presented and demonstrated by my esteemed member of our technical staff, Andy Insignia. Complimenting him and providing commentary and covering security will be our Director of Product Marketing, Ron Stein. So before we get started, we're going to do a little poll here on the launch. If you want to learn a little bit about you guys. So I just launched a question. If you take a moment to answer, I'd really appreciate it. Are any of your applications and or infrastructure in a public cloud now? If you take a second, no, not plan, no, but planning, migrating now, developing cloud native now, or yes. Take a moment to do that. Fantastic. Well, coming in, it looks like there are a bunch of people migrating now, so that's good. All right. Now here, Ron is going to be one of our presenters and give you a brief overview of what we're doing next. Ron, would you take it away?
Hey, thanks for that opening and for the introduction, Steve. And welcome, folks. Thanks for joining this live and somewhat virtual hands-on workshop. I'm going to be handing it over to Andy shortly. But first, I'll step you through the agenda that's already on your screen. We're going to cover how to instrument a public cloud environment for reliable performance visibility so that you folks can have an easier time of troubleshooting and isolating problems. That's going to include several live hands-on demonstrations, and the hands-on will be Andy's hands-on, so it'll be virtual, and you'll see how Andy is able to identify bottlenecks, performance issues, and other problem areas. After Andy does that, excuse me, after Andy does that, I'll come back and walk through a couple of security use cases, and then we'll have a wrap-up, and that's going to include the prize drawing, so make sure to stay through to the end so that you have an opportunity to win this week's this webinar's prize, which is a pair of true wireless earbuds. Then after we complete all of that, we'll do some Q&A. We'll also have another set of poll questions coming up in a moment as well, so let me thank you in advance for providing your input into the polls. And it looks like we've got some more updates to the polls as well. I'll just give you a quick heads up. About half of you are not planning to run applications in a public cloud. Well, now it's down to 40%. About a third of you are migrating, and roughly 15% of you are there now. So that's where the current poll stands, and let's move forward. So once you move from a data center to a public cloud environment, and some of you have probably already crossed this particular path, things are different. You don't have the ability to access hardware instances because mostly everything that you have is, if not everything that you have, is going to be virtual. Some of you might have some co-location and some of your own equipment, but a lot of you are going to have virtual. So that means you're not going to have access to network switch ports, as an example, or other sources of hardware. So you're going to need to get visibility and data in your public cloud environment in other ways using other tools. And that, of course, includes the usual suspects for public clouds, Amazon Web Services, Google Cloud, and Microsoft Azure. As a leading provider of network visibility solutions, we also have virtual instances or virtual implementations of our products that run in the cloud that solve that problem in terms of how do I get visibility to what's going on in the cloud regarding traffic flow and packet movement and so forth. There are three solutions that Andy is going to show you today. That's our CView packet broker, and the -V behind it means it's a virtual instance, so it's for the cloud. Similarly for CStore, our storage solution, that's capable of capturing and playing back packet information as well as making it available not only to our visualization tool, which I'll get to in a moment, but any other third-party visualization tool. And again, there's a -V after that because it's a virtual instance, so it runs in the cloud and does its magic that Andy's going to show you. And as I mentioned a moment ago, CClear, which is our analytics engine and provides data visualizations. It also provides all of the provisioning and management for all of the cPacket products. So you have the provisioning, management, analytics, and data visualizations available to you all from a single application through a single pane of glass. Collectively together, those and a couple of other products that we're not going to touch on today form our cCloud series, which provides visibility as a service in the cloud. So when you're in the cloud, products like these will provide visibility, and it will give you an ideal inter-cloud visibility that pretty much looks like this diagram on the right-hand side of your screen. Again, and that applies to whatever public cloud you are using. Once you have these solutions instrumented in the cloud, you're going to have visibility to network traffic so that you can efficiently maximize performance for end-user interactions with your applications and workloads, as well as IoT interactions with your applications and workloads. And of course, that's going to help you to maximize the experience that end users have, as well as any IoT-related processes. The other benefit of visibility, of course, as I'm sure you folks well know, is seeing and knowing what is going on from a traffic standpoint also really helps you to heighten and manage your security defenses. This is what an ideal cloud visibility solution looks like. When I hand over to Andy in just a few moments, he's going to show you a more detailed diagram and walk you through how to instrument the cloud specifically, and then how to actually use these particular tools. So with these solutions, you're able to acquire data, store data, and analyze data. And not only in just one cloud, but if you're running in multiple clouds, these things will span up across multiple clouds. And again, you'll have the ability to analyze and visualize from a single pane of glass using CClear. And it looks like this diagram here. And in fact, it goes beyond multiple clouds, but it also goes to your data center as well. So you can have complete visibility across an entire either multi-cloud environment or a hybrid cloud environment. All right, so that's all of the setup from me. So I'm going to put up the transition slide for when Andy steps in. But before we do that, I'm going to call upon my good buddy Steve. We're going to ask you two more poll questions really quick, and then Andy is going to take it over from there and give you the hands-on walkthrough. Steve, would you launch those polls, please?
I actually will. I absolutely will. So let's so the next question we're going to launch is, if you have an application and or infrastructure on-prem, your own data center, do you have an application and or infrastructure on-prem? Let's start voting. Please take a moment and vote. Right. Looks like some of you guys are using third-party network monitoring solutions. Let's also go to the next one here. Oh, wow, everyone's kind of jumping in there. So we'll let that update for a second. Move on to our next question. For those of you who have application and/or infrastructure in one or more public clouds, we'll launch that vote. And I'll give you a little update on our previous question about applications or infrastructure on premises. We have about 14% who neither use nor plan to use network monitoring and or traffic analysis. About 14% not yet, but planning or actively evaluating solutions. And about 57% monitoring or our network using network management system from a network infrastructure vendor, and about 14% with third-party network performance monitoring solutions. And let's see how we're doing with our other poll here. Oh, it's about evenly split here. So for those who have application and or infrastructure in one or more public clouds, about 20%. I'm not aware that visibility. I'm not aware that visibility to the network pack is available. Interesting. Both A and B above, which is I'm not fully aware of visibility and performance. And yes, I'm aware of network and performance data. About 50% of you. So fantastic. And with that, I think we'll turn that back over to Andy.
Hey guys, this is Andy, Cloud Architect with cPacket. All right, I'm going to turn on my screen share here. Here we go. Okay, good. So thanks for the introduction, guys. And I see that there already is a question from the audience about multi-cloud, so I'll be sure to answer that as we go. I'm going to start off today with a diagram describing a topology that we've set up for today's workshop. And the first thing I'm going to discuss is the core products that cPacket provides to increase visibility in the cloud. By the way, speaking about cloud, we're going to be talking about cloud today, but we also extend that out to on-prem virtualization infrastructure. So in some cases where these tests are run can be coming from workloads that are running on-premise and maybe spanning on-premise to the cloud. So starting in the middle of the diagram, at the top of the diagram here, this is our CVV packet broker. Now its key responsibility is to receive packets directed towards it. These are the packets that you need to be monitoring, right? Its key responsibility is to take those packets and then forward them downstream to other tools. Of course, in our case, we provide a storage, a packet capture and storage solution. We call that CStorV. And in this case, on the cloud, it's running storage to block devices. So you can imagine having quite a bit of storage, gigabytes, terabytes, and then with tiered storage features that we offer, you can even store potentially up to petabytes of storage in the cloud in blob storage or object storage like S3. But we do have a multi-cloud solution. In today's demonstration, we're actually running up on Azure, Microsoft's Azure cloud, and we'll be running our packet broker in an inline configuration, and I'll describe that a little bit more in a second. So the third key component here is our cClearV single pane of glass management and analytics solution. cClearV is managing both C-stores and C-views, packet brokers and storage devices. These are all virtual appliances, by the way. We distribute these as machine images and installers that are cloud specific, but otherwise these things are pretty agnostic in terms of the cloud or the virtualization infrastructure. So I just wanted to touch on that key question. The complexity, of course, comes in around the cloud configuration. So Azure versus AWS versus Google Cloud, the configuration, glue and the optimization and the automation around those is a little bit different, of course, on each cloud. But our stuff works the same. So that's a real benefit. When you already know and trust cPacket solutions, it's really easy to have multiple cloud solutions that multi-source your cloud support. Okay, so the next thing I'd like to talk about is just quick and briefly, we can, from our packet broker, of course we can send packets to our own solutions, but we can also send packets, replicate packets, if you will, off to third-party solutions. Third-party solutions that may want to analyze packets for security, for instance. And we work with Vectra. It's a company that does security products also in the cloud. It's one of the companies out there that does that. All right, let's talk a little bit about the network configuration of our topology here on Azure. Very similar to the way you might do it yourself, or you might do it on Google or AWS here. It just happens to be Azure today. So we set up 3 subnets. Starting on the left here, the 10.0.0 subnet. This is our stand-in for the workloads that may be on different subnets in the cloud. They may be different virtual private clouds or VNets, if you will, or these might be workloads running on-prem that have some traffic that need to go up to the cloud. Okay, so this is a stand-in for the clients really in our exercise today. Moving to the center here, we have a 10.0.1 subnet configured. We're calling this the monitor subnet. This is where we have our connections to our tools configured. So as the packet broker, our CVUV, is receiving packets on this red line across a workload network and a default network, right? The workload traffic. It's sending and sending data and talking to the CClear and CStore products on the monitor network. Now, this third-party tool, this can be, because we're using VXLAN, this can be any IP address. So it could be an IP address heading out on-prem, or it could be another subnet in the cloud. It doesn't really matter. We send this over VXLAN. Okay, so we create a special virtual network just for this tool traffic.
Hey, Andy,
finally,
let me jump in with a quick question, if I may. Sure. Looking at this diagram, I see that you've got 3 cPacket solutions in those blue boxes running right down the middle of the screen. What sort of effort might I look at in terms of taking those machine images that you mentioned, the installers and configuration scripts? Is this something I can do in 10 minutes, an hour, an afternoon, 10 days, 1 person, 10 people? What am I looking at in terms of the effort to get this instrumentation that you've diagrammed here?
Yeah, that's a great question. We're talking hours, not days, and with maybe 1 or 2 engineers. Typically, I've worked with customers who have their proof of concept cloud designs turned on already. So for instance, they'll have an Azure or an AWS account, and we can get this whole infrastructure up and running in an afternoon. So pretty quick and easy. And really that's one of the things I'm going to be highlighting today is how to get this stuff up and running and just how straightforward it is to start to analyze and gain additional visibility of your cloud infrastructure. Okay, so on the right-hand side here, we have our workload network, the 10.03, and we're just running another workload here. This is a VM. Both of these gray boxes are VMs, and all of these 3 virtual appliances are also virtual machines, and I'll show you that in a few minutes in the Azure console. So in terms of tools, in today's workshop, we're really using just a couple of tools in addition to, of course, our cPacket products. We're using the iPerf performance tool to generate workload traffic. So that'll allow us to see retransmissions, bandwidth utilization, and round-trip times through CClear. And we're also using ping to start off with a really simple round-trip time test. And we're going to then, in addition to these tools, we're going to use the Linux TC command, traffic control, you can look that up, to create losses and delays on both sides of this network. And then we're going to demonstrate how we can use CClear and CStore to both analyze raw packet data and analyze information that's being captured and presented to CClear. All right, so heading into the next piece of the workshop here, and before I get into the technical parts, I'm going to give you a quick walkthrough of our Azure console. Now, we just happen to be working with a customer on Azure right now with our inline product, but we also support Google Cloud, AWS, so this isn't a promo for Azure or anything like that, even though, of course, we do love VMware, KVM, and Cisco's NFVIS. We support all of those on-prem virtualized infrastructures. All right, I'm going to head over to our console now. This is our Azure console in the cloud. I'm looking at virtual machines. So we've started up a few different virtual machines, and I'm going to focus your attention on a few of them here. Here's our CClear virtual machine. This is running our CClear V virtual appliance. We have a CStore, just like in the diagram, and we have our CView V inline running. And then I have two machines that I'm using for the workload testing for the data. On the left-hand side of that diagram, we're running this machine called FileX Tester. This is where we'll run the iPerf client, and then we have our Linux workload. So all of these are running. You can see we have some other stuff up here too. This isn't just for today's demo. All right, I'm going to look at virtual networks really quick. I have a VNet defined up in Azure with a few different subnets configured, just like in the diagram. This is our monitoring network, 10.01. Our workload network that we'll be using today is 10.03, and our default network, 10.00. Now this is the really important part, and this is fairly different among clouds. On Azure, what we've done is we've set up some user-defined routes and attached those routes to different subnets. So this is the route tables, and I've created two for today that we care about. We have a route attached to the default network and a route attached to the workload network. So for the default network, you can see that it's attached to this subnet default 10.00. And on the in terms of the user-defined route, what we've configured here is any traffic with the address prefix of 10.03 is going to a next hop of 10.01.128. That is our CView. Okay, so let's just quickly take a look at the diagram again. We're talking about this interface and this routing configuration. Okay. And similarly on the workload network, we have it attached to the workload. This is the workload network route, user-defined route, and it's attached to workload network 2, address range 10.03. Now here's our user-defined route. Anything headed towards 10.00 is going to have a next hop of 10.03.128. And this is the Azure infrastructure. This is how we're configuring the Azure infrastructure to force packets to be directed towards our CView V packet broker. Now this is a little bit different in every cloud. Now in this case we're running in inline mode, so packets are effectively routed from one side to the other, passed through if you will, and then they're tapped in the middle and sent over VXLAN. On AWS we support running CView V in an endpoint mode, where it's not routing, it's actually just receiving traffic from AWS traffic mirroring. Similarly, on Google Cloud, we support Google Packet Mirroring, and you can tag your instances and have that traffic directed to CView V. And then all of the other stuff is the same. So cloud configuration, different across clouds, of course. cPacket products all act the same. All right. So let's get into today's workshop items. We're going to touch on round-trip timing, do a little bit of characterization and troubleshooting. We're going to touch on throughput with iPerf, and then we're going to introduce some delays and packet loss on each side of the network, and then demonstrate how CClear and CStore can help in all of these and make it easy and fast. So in terms of round-trip time, the first thing I'd like to do is I'm going to run just a super simple example with ping. We're going to look at our round-trip times. This is ICMP, right? We're going to capture those packets, so we're going to do a baseline, and then we're going to add some delay, and we're going to look at both of those. And this is going to provide us a basis for an introduction to our packet storage solution and what it can do. So let's head over to our Linux console. This is a TMUX screen in front of you. I'm sure most of you are familiar with this. I'm SSH'd into a Linux box, and then from there, I have two windows on the left-hand side connected to our file transfer tester virtual machine up on Azure. And on the right-hand side, I have the windows SSH'd into our Linux workload machine. Okay. On the bottom right-hand corner, I actually have our iPerf server sitting there and waiting on port 8051. So in a few minutes when we start running iPerf, we'll see this thing light up and show us. This is from previous tests I was running this morning. Okay, so let's run our ping and get our baseline. All right, so I'm running 2 pings per second just to generate a little bit of traffic. And we can see that we're right around a millisecond and a half of round trip time. So this is going to provide us the basis for an introduction to our packet capture solution. So let's head back over here. I'm going to go over to CStore. This is our CStore web user interface. I'm connected now into our CStore virtual appliance that's running up on Azure. And this is our data capture interface. So in a few seconds, we're going to download a raw PCAP data capture with the packets. But before we do that, I'm just going to show you a few of the things that we can see in this interface. First of all, up here we can see that we've grabbed about 59 gigabytes of traffic. This is just me and my testing, nothing fancy here. We can specify the number of seconds of data that we want to download. And by the way, typically the way operators are using this is they're trying to grab just a small portion of the packets for a particular point in time. So we support changing the time frame that you want to grab that. You may know, for instance, coming into this interface that you have a 2-minute period or a 5-minute period from yesterday that you want to grab the packets for, and you can do that in here. In our case, I'm just going to grab the last 10 seconds. We also have a maximum download size that you can specify because we don't necessarily want to download 40 gigabytes of packets. We just want to grab a few seconds and max it out. Now, when you have a lot of traffic moving through your packet broker and into your storage solution, CStore V, this can get pretty big. So typically, we're trying to just grab bits and pieces. Let's see what we can do here. CStore isn't just capturing packets. CStore, even though we're going to download raw packets, CStore has a variety of analytics functions that it can run on packets before you download. So you can effectively download just the output of the analytics. So you can see we analyze TCP sessions here. We get a bunch of counters, latency maps. And some of these things are interesting. XDP, that's market data. We have a lot of financial customers using our tools for visibility and performance optimization. And so, with those customers, we've developed a variety of analytics functions over the years. In our case, I'm just going to get a PCAP file, so let's just go ahead and download that really quick. It'll be pretty tiny, and I'm going to set this as our ping baseline because we still have ping running in the background. All right, let's take a quick look. So this is just launched right into Wireshark. This is just your off-the-shelf Wireshark. It's not packaged with our products. It's downloaded off the internet. So you can see CStore packet captures load right into Wireshark right away. And you can see CStore has been capturing a bunch of different things going on, right? It's not just 2 nodes talking. There's a lot of things that are going on between CStore, CView, and those 2 networks. So what I'm going to do here is I'm just going to apply a filter with the conversation that we care about, 10.0.0.6 to 10.0.3.4. And cool. And now we can see just our ICMP traffic because that's sitting there in the background running. And let's just take a look at one of the requests. You can see we have a request and reply. I'm going to set the time reference for this so that we can look at the following packets and get an estimate for what CView V thinks the timing is. Remember, CView V is capturing these packets in the middle. So here we have about half a millisecond. So our ping was showing us 1.5, so we can chalk up the half millisecond for the timing between CView V and the workload server on the right-hand side of that diagram, and the other bit of the timing for the left-hand side. So that's kind of interesting, right? We can kind of get an intuition already. I'm going to do another one here. Now this one, I hit the reply by accident. Let's grab one that's the request, set the time reference on that, and we can see similar results that match our ping. All right, now what I'm going to do is I'm going to head over to our console again, and while the ping is still running, I'm going to use the Linux traffic control tool on the server side of our topology, and I'm going to introduce some delay. I'm going to introduce 250 milliseconds of delay. Now, the whole point of all of this today is to introduce conditions on the network that we can then, of course, diagnose with the cPacket products. And we do have to be careful with this because it's easy to create delays and losses such that you lock yourself out with your SSH terminal. So you do have to be a little careful. Looking over here at the ping results, we see that we're at 251 milliseconds round trip time. So that's cool. things are working and acting as expected. Now, you wouldn't necessarily, obviously you wouldn't be introducing your own delays, but for testing, you could definitely do it to test various pieces of your network. And so we provide all of these scripts. We have a set of traffic scripts and traffic control manipulation scripts that we provide to customers and then help them diagnose their network designs when they move to the cloud. All right, I'm going to flip over to C-Store again really quick. Same thing, last 10 seconds. Going to look at 10 megs. It doesn't really matter. By the way, down at the bottom, we have captured data rate. We're only getting 11 kilobits going into C-Store right now, so there's not a lot happening on our CView-V packet broker. Remember, CView-V is the one feeding the C-Store with all of the packets that are going across it, right? All right, I'm going to download our new one. We're going to call this one ping delay. Save it. Let's open it. Again, we're going to come in here, look at our conversations. These are all the conversations in this packet capture. We'll apply our filter again. And cool, we can see our pings. Oh, that's interesting. Looks like we had a retransmission or a dupe there. So there we go. We can see something interesting already, and we didn't have to do anything fancy. All right, let's look at one of our requests and replies and see our timing information. I'm going to set our time reference. And there you see it. We have 250 milliseconds of additional time added on the reply. So where CView sees this, before we only had, about 0.8 or 0.6. Now we see an additional 250 milliseconds. So just using our straightforward, ping and Wireshark and capture solution, it's pretty quick and easy to get up and running with C-Store and doing some really basic diagnostics and taking a look at timing and gaining an intuition of where that problem may reside. All right, I'm going to go over here and I'm going to reset our traffic conditions. I cleared that delay and now we can see our ping is back to normal. All right, let's head back to the slides. So that's our basic round trip timing with delays and introduction to C-Store V, but there's actually a better way to do this than using raw packet capture for this. And for this, I'm going to give you an introduction to C-Clear V really quick, and then we're going to move on to iPerf. So this is our C-Clear user interface. C-Clear, just as a reminder, is our single pane of glass management and analytics solution. So in C-Clear today, what we're going to focus on is using the analytics in our dashboards, and right now I'm going to look at our configuration. So C-Clear can manage C-Views and C-Stores. It can manage them anywhere on your network as long as there's a TCP/IP route to either the C-Store or the C-View, and that means reaching across clouds to on-prem, managing from the cloud your on-prem devices if you have enough network capability between them, and so on. Now we've configured our C-Store here, and you can see that C-Clear is now aware of the traffic rate going into that C-Store, and you can have many C-Stores here. Now I just did a packet capture a minute ago and I downloaded the packet directly from C-Store, but can you imagine if you had 10 or 20 C-Stores instantiated around your network in a complicated system? You wouldn't want to go to each one to download packets from the data capture UI. In some cases you might, right, when you know exactly where the issue is. But in other cases you would want to come into the capture interface here, select all of your C-Stores, select your time frame, right, and then download the data that you need. And this gives you access to the raw packets from your C-Store devices. All right, thinking more about analytics, what we've done is we've configured what we call a network monitor. And we've named it default net to match our Azure configuration, and we've specified which address prefix and data that we want coming out of C-Store. So we're really just looking at anything on the 10 network that happens to be going through our C-View, right? That's the key. The C-View, it has to be seen by the C-View. C-View then is sending it over to C-Store, and that gets it ready for C-Clear. Now when you click on dashboards, it brings you over to a set of dashboards implemented in Grafana. We package Grafana and tightly integrate that with our C-Clear product. And I've created a set of dashboards for today's workshop. I'm just calling it Demo KPIs. We have a bunch of different dashboards. We have gauges, tables, and stats. These are big things that you can get a very quick view and then go into detail. But today, I'm just going to be focused on these. All right, so we can see that there's not a lot of data here right now because I haven't been running the tests recently, but we have the ability to look at TCP session packet counts and bytes. It gives you an intuition for bandwidth utilization and the breakdown of number of packets versus bytes, right? Lower packets, high bytes might indicate higher throughput, but it's basically showing you what you can expect as a baseline, and then you can look at the differences in that. We also have timing information, SYN to SYN-ACK timing, and then packet to the packet-ACK timing. This is for TCP, and these are measured at CView and CStore. So you're going to see the differences in the network latency and then the application processing on top of network added to that. We have that for both server side and client side. And then we have the ability to look at retransmits, client side and server side, and this is going to give you an idea where problems might exist in the topology on one side of the CVV or the other. And we'll demonstrate how that works in a bit. All right, so that's our basic introduction to ClearV. Let's move over to iPerf. Let's run iPerf and get a sense of timing and bandwidth with our baseline. No delays, just straight up iPerf. So I'm going to come back here. I've already reset. I'm going to do it again just in case. Reset both sides. So this is a clean configuration. No delays, no losses. I'm going to stop our ping. And now what I'm going to do is I'm going to run iPerf in a loop. So I have an iPerf script here. By the way, this is all straightforward, off-the-shelf stuff, a simple bash script. I'm going to run that in a loop. And I'm going to target 1 megabit. Nothing fancy here. We don't need to do gigabits, even though we can. I'm going to target 1 megabit and 10 connections. So basically, for 30 seconds, we're going to run this test, and it's going to report out the results and the bit rate. So I just hit that, and we can see every second it's outputting the bit rate. So we're hitting our target bit rate on each connection of about 1 megabit, and you can see the summary lines on the bottom showing, around 10 megabits per second. And you see the same thing on the server side. So this is the server lighting up. Now, the way iPerf works is when I run it in client, so the client is connected to the server, and I have it in regular client mode. So the client is doing all of the transmitting to the server, and the server is basically just ACKing those packets. And we can see that we didn't have any retransmits. Okay? So this is just our straight bandwidth test, and now let's flip over to CClear and take a look at what's been happening. So we can see that as we've been running that test in the background, CClear is now showing us packets. So look at that. We have a peak of 140,000 packets. By the way, I've configured iPerf to have really small packets just for dramatic effect here. But we can see there's a lot of packets, and then we can see that we've done about 36 megabytes of transfer here. So it gives you a good idea of packets versus bandwidth utilization. Scrolling down a little bit, we can see our server response times information. This is our timing information. So with TCP, with ping and ICMP, you're getting an idea for round trip time. But when you use a TCP tool, like iPerf, you can get a much more clear picture of what's actually happening both on the network and with the workload on the server. So the SYN to SYN-ACK is measured basically between the time when we see the SYN come by and then the SYN-ACK from the server. So we can see here we're looking at 300 to 600 microseconds round trip time. This is just our baseline, by the way. We're going to see that change in a few minutes. And look at this. Why is this one a lot higher? We're up in the milliseconds here. Well, that's because I've configured iPerf in a certain way, and this is basically a stand-in for application level processing of those packets. So this is network, and then this is the packet-to-packet ACK times, right? So we see the packet come through, and then we time when the ACK comes back. Now we can see both network plus application program processing time. So this is basically building our intuition for a particular workload on the topology, and we're establishing our baseline here. Okay. Good, baseline. Next up, bandwidth and timing, server delays. So what happens when we introduce delays on the server side of the topology? That's what we're going to demonstrate next. And then we'll take a look at how CClear handles that. All right, so the first thing I'm going to do is I just quit out of our iPerf loop, and I'm going to go and add delay. I'm going to add the same 250 millisecond delay I did for the ping, because we want to kind of do an apples to apples here. So now we've slowed down the server side of the network. Now, even though we've done this to the workload machine, this is an example that's just meant to illustrate what happens when conditions change on that side of the network, and then we run our workload again. So again, I'm going to run the same 1 megabit and 10 connections. And it's going to make our connections there, and we can see both sides lighting up. And we can see the megabits here is changed a little bit. We get some 10s. Make sure we got our delay set. Yep. We have lots of small packets. And we're going to wait
Andy,
for some data to come in.
quick question here while we're waiting for this screen to populate. If I come across some data that's of interest that I want to reference and go back to, how might I do that, or is that even possible?
Sure, yeah, that's a good question. So a couple of things here. We can, right now I'm looking at the last 1 minute. I can change the time frame, and we can see a lot of things happening here. By the way, we're seeing our data change right in front of us. But let's say we were looking at the last, say, 30 minutes, right? And we saw something specific that interested us. We can come in here, I can hold down my control key, and I can create an annotation right here. Look at this. And that's going to create an annotation. Now, when I go into 5 minutes, that thing's going to scroll over here. So basically, I can look at that annotation at another point in time. And I'm also showing you how we can zoom in on particular pieces of information, right? So as I'm moving my cursor around, you can see the red lines, the red vertical lines moving around in the other pieces. So if I'm looking over here, I can look at our packet-to-packet ACK timing information and see how that shows up over here with the same vertical line. Good question. So we've been running our data in our iPerf data transfer in the background. We're getting some megabits, so that's cool. But what happened on our view? Well, we went over here where we were in the milliseconds to, look at that. We're up over 100 milliseconds in SYN-to-SYN ACK time, and we're up to 250 milliseconds, which is what we expect because we created that delay. But this is how you can very quickly and easily see the actual network timing information for TCP workload. Now, one reason you might want to do this is because TCP packets are often treated differently by the routing infrastructure than ICMP packets. So this is, in fact, a much more useful way to be looking at this. And you can look at it in real time as it's coming through. There's just a little bit of delay as the packets move from the packet broker over to storage, and then when CClear sees this data coming in. All right, I'm going to go back and I'm going to clear that delay. And I'm going to quit out of our iPerf and head back to our slides. Okay, so bandwidth and timing, server delays. So what happens if there's a problem on the client side of the network? Let's say instead of delay, we actually experience some packet loss. Now, packet loss can happen for a variety of reasons. You may have very long fiber networks where there's corruption, and those are effectively going to be lost packets. There may be drops because of the load of some routing infrastructure. There may be drops or delays because of the workloads themselves. So what we're going to do is we're going to introduce some loss on the client side of the network, run iPerf again, and then we're going to demonstrate what that looks like in CClear. So I'm going to come up here. I'm still on my client, the Linux file tester. And I'm going to add, I'm going to configure it for 30% loss. 30% it's wishy-washy. It's not actually 30%, but what I'm really doing is I'm using the TC command, the traffic control command, to use to introduce loss using one of the modules there. So that's the important takeaway, not necessarily the 30% value. Okay, I'm going to run our iPerf client, same one again. And this is introducing loss on the output of this Ethernet interface, right? So it's really being created on this machine itself. And we're going to see what happens. Now we can see our bit rate dramatically dropped, and we have a lot of retries here being indicated by iPerf. So this is interesting, right? We have retries, but why is iPerf retrying, right? Well, if we come over here to CClear, I'm going to scroll down a little bit to this section. It could be retrying for a variety of reasons on your network, but when we look at CClear, we can see that this is dealing with retransmits from the client side and not the server side so much. So we're starting to get a lot of retransmits, and we saw those showing up in iPerf, and now we can see that here. So what this is really telling us is that the loss that's been introduced on the client side of the network is now visible in CClear, and it's directing the operator's attention to that side of the network versus the server side. Okay, and that's really important because you're not necessarily going to come in and run a bunch of tools. You want to be able to see what's happening quickly and easily. Now, I mentioned earlier that we have different dashboards. You don't necessarily have to come in and look at delays like this. You could set up a gauge for a particular set of applications. Notice I have a lot of node information here for what's going on. If I unclick this, you can see there's a bunch of nodes. I'm focusing in on a couple, right? But you could have a gauge set up for a particular node if it's critical to your infrastructure. Again, if I zoom in, we can look at that. And as I scroll, I can see what was happening in terms of packet timing, SYN timing, and retransmits. And notice I'm not getting any retransmits on the server side, so it's really focusing our diagnostic attention to this side of the network. All right, I am going to stop that test, and I'm going to reset our configuration, and I'm going to come back to the slides. There we go. So that's that. Now, same thing, nothing fancy here. We're going to do the same thing on the server side. I'm going to introduce some server-side loss, and then I'm going to run iPerf in such a way that it causes the server to do all the data transmission. And then we'll see those losses show up on that side. I'm going to go through that one just a little bit quicker because we've already seen the net effect on the client side. So I'm going to go over here to the server, run the same loss, 30%. I'm going to run iPerf again. Now this time I'm going to run it in reverse mode. It's just a configuration option for iPerf. It still connects to the server, but it instructs the server to do all the sending, the data transmission. All right, see what our bit rates look like. Similar to last time when it was on the client side, you can see bit rates. And now this time we're seeing all the retransmits on the server side because we have problems on that side of the network. So you do get a little bit of an intuition from iPerf. I'm going to reset our time. And there we go. We can see a similar thing happening. I'm going to change the time range to 1 minute. Zoom that in a little bit. So last 1 minute, we're seeing a whole bunch of server retransmits occur. Client-side round trip is really increased. And we see our packets significantly drop from before. We were up in the tens of thousands, and now we're much lower. So we can see something is definitely going on here. we look at the past hour, we can see a few different times with all of our data. So we have a lot of options here. All right, so that wraps up the really technical part of the presentation. And I'm just going to sum this up with some of the things we delivered. There was a question earlier about multi-cloud. And so in terms of delivery, we are providing cloud-specific images and installers, depending on what the customer needs. So on Amazon, Google, Microsoft will provide Amazon machine images, Google images, or disk images on Microsoft Azure. We also provide installers, so there's the option to bring your own instance, Ubuntu instance, and we have some Tarball installers that can be used on virtual or in test infrastructure. VMware, we provide VMware images. Example scripts, all of the test and test scripts we looked at today, traffic generation, control, we provide all that. That's just all straightforward stuff. And then we provide assistance, in fact, to help with configuration and dashboard and analytics configuration to the customer needs. In terms of automation, we mentioned earlier that this stuff is really easy to get up and running. In terms of automation scripts, what we typically do is we provide bash scripts with the cloud-specific CLI tools. So on AWS, we'll provide a set of bash scripts with configuration files that really show how simple it is to script creating the network interfaces and creating the virtual appliances with the machine images we provide. So with those scripts, you can turn on and off infrastructure fairly quickly. Those scripts also provide a basis for horizontal scaling, running multiple C-stores, multiple CPUs, and then putting them at different spots of the network. All right, Ron, I think I'm going to hand it back to you.
Hey, that was really cool walkthrough, Andy. Thanks so much, and particularly the summation there as well. My takeaway is that everything's available out of the box. So great job and thanks. I'm just going to take one real quick moment and go through a couple of other real quick topics. And the next topic really is, once you have instrumented visibility in the public cloud, how that can help provide network intelligence that will aid with cybersecurity. And then once I touch on that, we'll get to the wrap-up and then the Q&A. So aiding cybersecurity, of course, is providing visibility and data, and that's essential for creating secure experiences to assure that data privacy is upheld, digital assets are protected from malicious attacks, as well as also detecting and stopping certain types of performance attacks, such as distributed denial of a service or other flood attacks. Deeper cyber threat intelligence is not something that CPacket does on its own specifically. Rather, we feed the data for network traffic analysis, for deep packet inspection to understand user and entity behavior analysis, or UEBA as it's often abbreviated. In these cases, the CPacket visibility stack provides the data to third-party tools from companies like Vectra and so forth, who will do their own type of network traffic analysis, deep packet inspection, user and entity behavior analysis, and so forth, as well as our solutions also feed data into a security event and information management or SIM system. We provide data in two ways to these tools and these solutions, and also some information from CClear as well will be helpful for your analysis and understanding of malicious and suspicious activity. The two types of data that we provide are real-time data, and that aids with attack detection and threat intelligence, again, mostly with third-party tools. And as Andy showed us, we have a C-store solution for storing data, and that's really helpful for after-action forensic analysis and mounting an appropriate incident response so that you have the data there. And by the way, just as an aside, that recorded data is also really helpful for regulatory compliance as well. So that's just a couple of quick comments about how instrumenting a public cloud for troubleshooting also provides value for your cybersecurity defenses. That gets me to a point to wrap up this particular technology section of the webinar. And I would be remiss if I didn't share with you folks that over more than 13 years, we've deployed over 10,000 devices. And as Andy had shown you some great frustration reducing and time-saving tips using our solutions, our customers are telling us that they're getting a 30% or better reduction in their operations and cost of ownership. Our solutions, as we tend to talk about them, are fully reliable, and as both Andy and I shared with you, they will distribute across a single cloud, multiple clouds, and hybrid environments, and they're fully integrated and fully reliable and tightly integrated across those environments. And also, as Andy mentioned, getting this whole infrastructure up that he showed you with or without assistance from someone like him or one of our sales engineers or part of our professional services team, that's all within a handful of hours and certainly within a workday afternoon, so to speak. So reliable, tightly integrated, and consistently simple are among the mantras that we bring forward in our products and solutions. So the key takeaways that I would like you folks to have is we featured 3 of our virtual solutions that form our C-Cloud series of products. Those solutions are our C-View Packet Broker, our C-Store Packet Storage, and our C-Clear Analytics and Management Engine. They scale for virtual monitoring to give you visibility in any public cloud, as well as also Andy mentioned, but worth reiterating, if you have virtualized environments, you'll be able to use them there as well. And as I just mentioned, they're reliable, integrated, and simple, and I'll also add that they're very cost effective and they are also open, and by open I mean that they have APIs and they easily integrate with other third-party tools, as I alluded to a moment ago, for use in your security defense efforts. When you use our products with other common tools that you're probably familiar with, such as Ping and iPerf and Wireshark, you can probe the network, create test packets, and all of those sorts of things that Andy showed you in the tips and techniques to find and analyze bottlenecks, packet loss, threats, and so forth. That's all I have to share with you folks. We were going to launch another poll, but we're going to skip that poll just because we're running up the tail end of the hour and we do want to get to some Q&A. And of course, we're going to bring Steve back, as I mentioned, to cover the winner of the registration prize. I'm going to leave up on the screen while Steve does that some related resources to the topics we discussed today, and those resources are also available for you to download from the attachments section of your viewer console. Thanks again, Andy especially, and everybody else who's joined this webinar. Steve, do you want to walk folks through the final housekeeping items and the prize winning? And we should have time for at least 1 or 2 Q&As to pick out of the audience.
Happy to do it. This is now we're going to give away a pair of very, very cool wireless earbuds. So unfortunately, I'm not going to be able to win those because there are a couple of restrictions. So just kind of let you know a little bit. So to win the earbuds, we're going to do a little drawing here really quick. You must be present to win. You must provide your contact information, including a business or organizational email. Personal private emails or free emails like Gmail and stuff do not qualify. You can't work for a competing organization. You can't be an employee or partner of C-Packet Networks. And you must be able to accept small value gifts, and you'll know if you're able to do that. And you must have registered for the live webinar before posting the starting time. So, and with that, the winner is Oliver B. Oliver B., congratulations. You will soon receive an email about how to collect your prize. And again, Oliver B., you are the winner for attending. Thank you very much. On behalf of Thursday, I really appreciate everything you do, and I'm going to turn this back, and we have a couple of great questions. Ron, you want to go and take it over?
Andy, there's a couple of questions about resolution, accuracy, and microburst. I'm going to defer those to you if that's okay.
Sure, yeah. A couple of questions in there about timestamping, and those are really good questions. In fact, that's a really critical part of this. So on our physical appliances, we have very, very accurate timestamping from hardware. In terms of the cloud, we're really at the mercy of the underlying network infrastructure. Now, what we do support is we use the data plane development kit to access the underlying NIC hardware. So when we're running on virtual machines in the cloud, for instance, on AWS ENI interfaces, or on Azure interfaces that have accelerated networking, those reach right down to the Mellanox cards or to the AWS enhanced networking cards. We get better time stamping. So that's pretty important. So the time stamping is basically going to be as accurate as what the NIC is providing us on the cloud. So it's generally pretty good, but not quite as good as our very high-speed hardware that runs on-prem. In terms of microbursts, we would, there's definitely an opportunity to work on those. We'd probably have to talk to you a little bit more and get more detail about the scenario. But yes, the answer is we can definitely track those things down.
Okay, we have now gotten not only to the top of the hour, but slightly past the top of the hour, and it turns out there were a handful of questions. A couple of we answered during the course of the presentation, and the last few questions were all tied together in terms of time stamping, microbursts, and resolutions. That said, I'm going to turn it back to Steve to end this particular webinar, and if you've got any closing remarks in terms of coming attractions or anything else, over to you, Steve.
Fantastic, Ron. I want to thank everybody for being here today. And remember, we have an attachment section. There are a bunch of resources, including a download resource page with a bunch of links that you might want to do. So again, thank you very much. Take a moment to give us some feedback, if you would, about what we can do better and how to make this hour more valuable. Thank you for joining us today.